Assalamu alaikum. So today we are going to start off with integration. All right. Okay. So what is integration? Integration is basically the reverse process of differentiation. In differentiation, we use the equation of the curve to find the differential function, which we call dy over dx. In integration, we are going to do the exact opposite thing, right? We are going to use the differential function to find the equation of the curve. All right. So just write this down. Integration is the reverse process of differentiation, while differentiation, wait, while differentiation is used to find the gradient function, to find the gradient function, integration is used, integration is used to find the equation of the curve. The equation of the curve. And not only equation of the curve, area under the curve, as well as volume generated when the curve is rotated. In order to understand integration, we will apply several models, right? So we are going to follow the same approach as we did when doing differentiation. So let's start off with our very first model, model number one. Let's say we need to integrate this, right? So what we will do is that x n plus 1. Wait, my x and n look quite similar. Let me just change that. N plus 1 upon n plus 1 plus 3, right? I will tell you in a while why the c comes here, right? So let's say we have ty over tx is equal to x3. So that would be y is equal to x3 plus 1, which is 4 upon 4 plus 3. All right. Let's say we need to integrate this. So that would be y is equal to x12 plus 1, 13 upon 13 plus 3. All right. And now why does this c come here? Okay. So I want you to write a separate note on that. When integrating, when integrating, we add c we add C to the result, to keep the place value, to keep the place value of the constant that was dropped, that was dropped when the function was differentiated, and the function was differentiated. All right. If point on the curve is known, if point on the curve is known, the value of C can be found. The value of C can be found. If the function is differentiated and the result is integrated, and the result is integrated, we achieve the same function. We achieve the same function because integration is simply the reverse process of differentiation, as we studied earlier. So I hope this is clear. Let's jump on to model number 2. Okay. So model number 2. Model number 2. Right. So ty over tx AXN. So we are going to integrate it the same way. All right. So y would be AXN plus 1 upon n plus 1 plus c. Let's do an example. Let's say we have dy over dx is equal to, let's say, 6x cubed. All right. So let's integrate this. So this would be 3 plus 1, 4 upon 4 plus c. This cancels out, right? So we are left with 2x power 4 plus c. All right. Sorry, my bad. When we cancel this out, we are left with 3 upon 2, right? 3 upon 2 x4 plus c. Okay. So I hope this is clear. Model number 3. Model number 3. dy over dx is equal to a, where a is a constant. So whenever we encounter a constant, what we simply do is just add x to it and plus c. So this is how you integrate this. Okay. So let's do an example. dy over dx is equal to, let's say, 5. All right, so it would be 5x plus c. And let's say we need to integrate 18. So it would be 18x plus c. I hope this is clear. Now a slightly more lengthy question. Plus 12x squared minus 8x plus 7. All right. So let's firstly differentiate this and then try to integrate it. And let's see whether we get the same answer. Because here we said that because we earlier said that integration is the reverse process of differentiation. So now let's see whether that's really true, right? Let's differentiate this and then try to integrate it and see whether or not we get the same answer. Okay, so let's firstly differentiate this. 15x squared plus 24x minus 8. All right, and now let's integrate this. Okay, so if we integrated on 4 minus 15x3 upon 3 plus 24x squared upon 2 minus 8x plus 3. All right, so this cancels out. Was a 15, 2 ones are 2004. So this gives us x power 4 minus 5x cubed plus 12x squared minus 8x plus c. So yes, we do get the same answer. All right. What we studied, integration is truly the reverse process of differentiation. And now you know why we add c here, because c is the place value which was lost when differentiating. All right. And now if we, let's say, if we somehow know the value of x and y, we can surely calculate the value of c. All right. So moving on. Model number 4. Let me just write it with a black pen. Model number 4. All right. All right. So ax plus b power n. Okay. So how would we integrate this? When integrating this, we will just add n plus 1 and n plus 1 multiplied by a, which is the differential of the bracket. All right, a differential of the bracket plus c. And one thing very important to note here is that you will only do this when the equation inside the bracket is linear. Let me just write it down, where ax plus b is always linear. Let's say if there were ax square here, all right, so then you cannot do this. All right, then this would give you the wrong answer. This formula of integration is only possible when ax plus b is linear. No matter what the power is, this must always and always be linear. All right, so let's do an example of this as well. Let's say we have, all right, so we need to integrate this. So that would be 4 upon 4 into differential of the bracket, which is 3 plus c, right? So it would be, right? Similarly, another example, 1 upon under root 4x plus 1. All right, so let's just rearrange this first. All right, for the sake of easiness, 4x plus 1 can be rewritten like this, right? Minus 1 upon 2. So y would be 4x plus 1 minus 1 upon 2 plus 1 is 1 upon 2 upon 1 upon 2 into differential of the bracket, which is 4 plus c. So finally, it could be written as under root 4x plus 1 upon 2 plus c. All right, so this is how you do it. Okay, so model number 5, definite integrals. Definite integrals, or more simply, integration within limits. All right, let's take a look. Let's say we have a differential function which we need to integrate, and it has limits with it. What we will simply do, integrate and write the limits, which will eventually be fp minus fa. Let's do an example. So we have our example here. All right. So we will simply apply what we learned. 4x square upon 2 minus 5x. All right. It would be 2x square minus 5x. We have this fx now, right? And now we will apply the limits of 5 and 1. So 2 5 square minus 5 5 fp minus fa to 5 1. All right. So that would give us 25 minus 2 minus 5 is minus 3, which would eventually turn to positive 3. So this would be 25 plus 3, which is 28. All right. So this is how you do integration within limits. And one thing you must have noticed here is that we did not add c here, right? When differentiating, we did not add c here. And that's because, write a note, when performing integration within limits, when performing integration within limits, there is no need to add c. There is no need to add c to the results to the results because c will eventually cancel off. C will eventually cancel off in the end. You can experiment if you want. You can place C here and you can see what happens to C if you move forward with it. That's something I will leave to you. Okay. And eventually it will cancel out, but you can try it if you want. Okay. So, yes.